In this episode, we start by making a simple idea feel solid and reliable, because recognizing personal information is the first skill that everything else in privacy engineering depends on. If you cannot consistently tell whether a piece of data is personal information, then you cannot correctly apply privacy principles, you cannot choose the right controls, and you cannot respond properly when someone asks about their data. For brand new learners, the challenge is not that the definition is hard, but that real systems rarely store data in neat, obvious labels like name and address. Instead, personal information shows up as identifiers, device signals, account details, behavioral patterns, images, and combinations of data that become identifying only when you put them together. The exam expects you to handle those subtleties, because that is what privacy engineering looks like in real organizations. You will learn how to think in categories, how to use context to decide meaning, and how to avoid common mistakes that lead to either overprotecting everything or underprotecting what matters most. Once you gain this skill, many other topics become easier, because you will be standing on firm ground rather than guessing. A useful starting point is to separate the idea of personal information from the idea of sensitive information, because beginners often mix them up. Personal information is any information that relates to an identified person or a person who could be identified, directly or indirectly, using reasonable means. Sensitive information is a smaller group of personal information that can cause greater harm if misused, like certain health details, certain financial identifiers, or information that could lead to discrimination or serious risk. The exam often tests whether you can recognize personal information even when it does not feel sensitive, such as a device identifier or a user account activity log. It also tests whether you can recognize that a single data element might not identify someone alone, but can become identifying when combined with other data. This is why privacy engineering focuses on linkability, meaning whether data can be linked to a person, and identifiability, meaning whether the person can be determined. When you learn to think in linkability and identifiability, you stop relying on gut feelings and start making consistent decisions that you can explain. Direct identifiers are the easiest category, and you should be able to recognize them instantly because they are often used in exam scenarios as clear signals. Names, government identifiers, account numbers tied to a person, and personal email addresses are direct identifiers because they point straight to an individual without needing additional work. A phone number can be direct when it is personal and not shared widely, and even if it is shared, it can still identify a specific person within a system. Home addresses and precise location data can also act as direct identifiers, especially when combined with a name or an account. Photographs and video can be direct identifiers when a person is recognizable, even if no text label is present. Voice recordings can also identify someone, which matters because modern systems store voice and audio as data, not just as communication. The exam wants you to recognize that personal information is not limited to text fields in a form, because personal information can be any data type that relates to a person. Indirect identifiers are where beginners make their first big mistakes, because indirect identifiers do not look like classic personal details. Usernames and screen names can be indirect identifiers because they might reveal a person directly, or they might become identifying inside an organization's system even if the outside world cannot map them to a human. Device identifiers like a mobile advertising identifier or a persistent cookie value can be indirect identifiers because they can track a person's behavior over time and link it to an account or a household. Internet Protocol, IP, addresses can be personal information depending on context because they can be linked to a user session, a device, or a household, especially when combined with timestamps and other data. Employee IDs inside a company can be personal information because the company can map them to real individuals, even if the number means nothing outside the organization. Even something like a student record number or a loyalty card ID can be identifying in the systems that store it. The exam tests this kind of reasoning because privacy engineering is about what the data can do in context, not what it looks like at a glance. Context is the key that turns uncertain cases into clear answers, and you should practice thinking about context in 3 layers: the system context, the organizational context, and the outside world context. System context asks whether the data can be linked to an identity within that system, such as logs that connect a device ID to a login event. Organizational context asks whether the organization has other datasets that can be combined, such as customer profiles, billing records, or support tickets that allow re-identification. Outside world context asks whether data could reasonably be linked using public sources or common techniques, such as combining location patterns with publicly available information. A dataset of anonymized purchase patterns might feel non-personal until you realize the organization can link purchase patterns back to accounts through transaction IDs. A list of web browsing events might feel anonymous until you realize the device identifier is persistent and tied to an account. The exam expects you to handle this layered thinking because many privacy failures happen when teams treat data as non-personal simply because one system field does not contain a name. If you treat context as a required step, you will avoid that trap. Another important concept is the difference between data that is about a person and data that merely passes through a system where people exist. For example, system performance metrics like CPU usage usually do not relate to a person, even if they come from a device a person uses. But if those metrics are tied to a specific user account or used to evaluate a person's behavior, they start to become personal information because they relate to that person in a meaningful way. The phrase relates to is doing a lot of work here because data can relate to a person by identifying them, describing them, evaluating them, influencing decisions about them, or being used to treat them differently. A log entry that records a failed login attempt might relate to a person if it is connected to their account and used for security decisions that affect their access. A location ping might relate to a person if it is used to infer home address patterns or movement habits. The exam often tests this relational thinking because privacy engineering is not only about who you are, but also about what data says about you and how it is used. When you think in terms of relation and use, you make more accurate calls. You also need to recognize personal information across different system layers, because personal information can hide in places new learners do not expect. Application databases store profile records, but personal information can also be in logs, analytics events, error reports, customer support tools, and backups. It can exist in file uploads, chat messages, images, scanned documents, and form fields that allow free text entry. It can appear in derived data, such as a risk score, a recommendation label, or a segmentation category, because those outputs relate to a person and can influence how they are treated. It can appear in metadata, such as timestamps, geolocation tags, or message headers, because metadata can be linkable and revealing. It can appear in internal data pipelines, where raw events are combined and enriched, turning previously non-identifying records into highly identifying profiles. A privacy engineer must assume personal information can spread through systems unless controls intentionally contain it. The exam checks whether you understand this reality, because recognizing personal information only in obvious places is a common reason privacy controls fail. A key skill for exam success is understanding pseudonymization versus anonymization, because questions often test whether data is still personal when identifiers are changed. Pseudonymization means replacing direct identifiers with a code or token, but the data can still be linked back to a person if the key or mapping exists. Anonymization means the data is processed so that individuals cannot be identified by reasonable means, including when combined with other data that is likely to be available. Beginners often assume that removing names makes data anonymous, but in many real cases it remains personal because patterns, rare attributes, or linkable identifiers still exist. A dataset of location traces without names can still identify people because movement patterns can be unique. A dataset of purchase histories can still identify people if the combination of items or times is unusual and can be matched to other information. The exam is testing whether you can avoid being fooled by superficial de-identification and instead evaluate re-identification risk. If you can explain why pseudonymized data is still personal information, you will handle many tricky questions correctly. You should also understand the idea of data categories and special handling, not as a memorized list, but as a way to reason about impact and required safeguards. Some types of personal information carry greater risk if misused, such as certain health information, certain financial identifiers, certain government identifiers, and information about children. Biometric data, like face templates or fingerprints, can be especially sensitive because you cannot replace it the way you can reset a password. Precise location data can be sensitive because it reveals patterns of life, like where someone sleeps, works, or visits. Communication content, like messages or call recordings, can be sensitive because it can reveal relationships and private details even if the system did not intend to collect them as structured fields. The exam may test whether you recognize that sensitivity depends on context and potential harm, not only on a label. It may also test whether you choose stronger controls and stricter use limitations when sensitivity is higher. If you train yourself to ask what harm could occur if the data were misused, you will make better decisions about classification and safeguards. Another area where new learners struggle is recognizing personal information in aggregated or statistical forms, because aggregation can reduce identifiability but does not automatically remove it. Aggregated data that truly cannot be traced back to individuals may fall outside personal information, but aggregation can be weak if the groups are small or if the data includes outliers. For example, a report that shows the behavior of a tiny group might allow someone to infer what one person did, especially if a person is the only member of a category. Even when aggregation is strong, if the organization can drill down from the report into underlying records, the overall system still handles personal information and must be governed accordingly. The exam often tests whether you can see that privacy is about what the organization can do with the data, not just what is shown on a dashboard. You also need to recognize that derived insights can still be personal information, like a fraud risk score or an eligibility label, because those insights relate to a person and can affect them. Thinking this way helps you avoid simplistic rules and instead apply consistent logic. Misconceptions are important to address because they lead to predictable mistakes on both exams and real privacy work. One misconception is that only data in official fields counts, like a profile name field, while logs and free text fields do not. Another misconception is that work-related data is not personal information, but employee and student data can be personal information because it relates to individuals and can affect them. Another misconception is that public information is never personal, but public availability does not eliminate privacy obligations, especially if data is repurposed in ways people do not expect. Another misconception is that if data is encrypted, it stops being personal, but encryption protects confidentiality and does not change the fact that it still relates to a person. Another misconception is that privacy is only about secrecy, when privacy is also about fairness, transparency, and appropriate use. The exam likes to test these misconceptions subtly, often by offering answers that sound reasonable but rely on flawed assumptions. If you can spot the flawed assumption, you can choose the answer that aligns with privacy engineering reality. To make this concrete without getting tool-specific, practice using a simple mental walkthrough whenever you encounter a data element in a scenario. First, ask whether the data identifies a person directly or could identify them indirectly when combined with other data. Second, ask whether the data relates to the person by describing them, evaluating them, influencing decisions about them, or tracking behavior over time. Third, ask where the data might travel, such as into logs, analytics, vendor systems, backups, or derived data sets, because travel increases exposure. Fourth, ask what controls and documentation would be expected, such as classification, access limits, retention rules, and evidence of handling. This walkthrough is not a rigid checklist you recite, but a thinking habit that keeps you from missing what matters. It also prepares you for later domains, because once you can recognize personal information, you can apply principles, risk assessments, and technical controls more confidently. Over time, you will feel your decisions become faster because you stop debating what counts and start applying a stable definition consistently. As we close, recognizing personal information precisely is the gateway skill that supports everything else the CDPSE exam tests, because you cannot govern, assess risk, map data flows, or choose safeguards without knowing what data you are dealing with. Direct identifiers are only the obvious starting point, while indirect identifiers, context, linkability, and derived data are where exam questions become more realistic and more challenging. Personal information can appear in any data type, any system layer, and any stage of the data lifecycle, and it can spread through logs, analytics, support tools, and backups unless managed intentionally. Pseudonymization does not remove privacy responsibility, and aggregation does not automatically eliminate identifiability, so you must think in re-identification risk and reasonable means. If you train yourself to reason in terms of what data can do in context, how it relates to a person, and where it travels, you will make consistent decisions that align with privacy engineering practice. That consistency is exactly what exam questions are looking for, and it will also make the rest of your learning feel easier because you are no longer guessing at the foundation.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.